In this next video, we are going to look at negative exponents, but combine that with product and quotient laws. So we're going to simplify each expression so that no negative exponents appear in the final result. So if I look at a question like this one, I have 5 to the 7 divided by 5 to the 9. I can use the quotient rule to say that this is 5 to the 7 minus 9, which would leave me with 5 to the negative 2. That's a negative exponent, so then I have to make this positive by saying that this is 1 over 5 to the 2. Or some people might go even further, and the textbook will often say or. I can do this as 1 over 25. So at this point, really, when they say or, it means either of those are acceptable answers. This is my answer with a positive exponent. This is just it evaluated. So I will take either. And I will say as well that when I'm doing these questions, I don't do the quotient rule as it states. I don't go 7 minus 9. Instead, I use the quotient rule to go 9 minus 7. And if I do 9 minus 7, my answer goes on the bottom. If I do 7 minus 9, my answer goes on the top. So I could have jumped right from there to there with skipping the negative exponent part. So if you're someone who recognizes that, feel free to do it if you want to. If you're just like, what is she talking about? Always go top exponent minus bottom exponent, write your answer, and then put it to the bottom if you have to. So why don't you pause the video and give this one a go. So again, if you're very literal, you're going to take this one and go, this is m to the 8 minus 13, which is going to give you m to the negative 5, which written with a positive exponent would be 1 over m to the 5. If you were someone who went straight from here to here, because you recognize that you could do 13 minus 8, there was more m's on the denominator, I'm totally okay with that. I don't need these steps to give you marks. All right, next two here. Just throwing in the quotient rule, but with some negative exponents as well. For this one, sometimes people who do the bottom to the top stop doing that because they're like, oh, I don't know, there's negatives there. I don't know what to do. It's totally fine to always go top minus bottom, write your answer on the top. So this would be negative 2 minus 4, which would give you m to the negative 6, which written with a positive exponent would be 1 over m to the 6. If you're someone who went 4 minus minus 2 and then wrote your answer on the bottom, that's awesome. Okay, next one. Again, I'm just going to do it as d to the, since this is dividing, I'm going to divide, or I'm going to subtract my exponents. That's negative 2 minus negative 5, which is going to give me d to the negative 2 plus 5, which gives me d to the 3. It's an answer with a positive exponent, so I don't have to touch it. The next two are dealing with the quotient rule. Sorry, not the quotient, the product rule. So when multiplying powers of the same base, you add the exponents. So this would be 4 to the 4 plus negative 6, which would give me 4 to the negative 2, which would give me 1 over 4 squared, or 1 over 16. I was about to say, you could also stop. Sometimes when I do videos, I get really excited about all the things you could do. And if you have seeing you in person, I feel like I would do it. But I feel like just knowing that, it's cool. I'm really fighting myself here. Yes, that's great. Moving on. Okay, for the next one, just if anybody has a question about a different way to do that one, feel free to come and ask me and I'll tell you. All right, for this next one, again, they're multiplying. So when multiplying powers of the same base, you add the exponents. So then this is going to give me m to the negative 6 plus 3 is negative 3. And then again, I want to answer with a positive exponent. Alrighty. Next two here is, this one's just a big quotient rule, but this one's got a couple of the rules in there. So let's look at this one first. When I look at this one, I have negative 32, a to the 4, b cubed on the top, so there's nothing to be done on the top. I look at the bottom, I have 8, a to the negative 2, b to the 5, there's nothing to be done on the bottom. So then I look at the fact that I'm going to divide. I have negative 32 divided by 8 is negative 4. Then I have a to the 4 divided by a to the negative 2. When dividing powers with the same base, I subtract the exponents. And same thing with the b. When dividing powers with the same base, I subtract the exponents. And you end up with negative 4 times a to the 4 plus 2 is 6. And then b to the 3 minus 5 is negative 2. Then you always want to answer with positive exponents. So we're going to move this b to the bottom, and we get negative 4a to the 6 over b squared. And that would be my final answer. And again, there's more than one way to do this. I will mention, I'm still not going to show it, but I will mention some people just get freaked out by having that negative exponent there and they want to get rid of it. So same thing here. Some people might look at this one and be like, oh, I don't like it. I'm going to move that a squared to the top first. It's going to work out the same. There's more than one way to reach the answer for these questions. So, having said that, let's just look at this one. I said I wasn't going to, but I feel like it's worth seeing. Some people look at this and they're like, oh, it's a negative exponent. Let's get rid of it. This will be 4 to the 4. And since this is multiplying, I can just put it on the bottom, 4 to the 6. And then they're dividing powers of the same base. So you'd get 4 to the 4 minus 6, which would be 4 to the negative 2, which I would then write as 1 over 4 squared. So it's just a slightly different way of doing it. What it is that in this question, we had to deal with the product rule and a negative exponent. And it doesn't matter the order you do it in. Negative exponent, then it would change to quotient rule, or product rule, and then deal with that negative exponent. So just know that if you're doing these questions a different way than I did, it's probably okay as long as we get to the same result. If you have any questions, just come and ask. This last question here, when I look at this one, I have 3km times m squared in the top, and then I have a 6k squared m to the 5 in the bottom. When you're looking at fractions, it's always a good idea to simplify your numerator and your denominator separately and then make your last step division. Not that you have to, but it's just the general BEDMAS rule. So when I look at this one, in the top, I have 3 times k times m squared. So I'm going to multiply powers of the same base, which is going to make me add the exponents. And then I'm going to leave my denominator the same because it's all simplified. That's going to give me 3k m to the 3 in my numerator. And then my denominator, I have 6k squared m to the 5. Now what? Well, now I'm dividing powers of the same base. Now, first thing I'm going to look at is this 3 over 6. So for 3 over 6, I'm going to simplify it by saying 3 goes into each once and twice. So I'm going to leave the 1/2. And then I've got my k. So this is a k to the 1. Some people might look at this now and be like, oh, look, there's one more k in the bottom. I'm going to put the k down here. Other people look at this and they're like, I'm just going to do my quotient rule. So I'm dividing powers of the same base. I have k to the 1 minus 2. Then I have m to the 3 minus 5, which would leave me with 1 over 2, k to the negative 1, m to the negative 2. So to leave those with positive exponents, I'm going to leave that 1 up top. I'm going to leave the 2 on the bottom. The k will come down, and the m squared will come down. And this is my final answer. So even if you took another path to get there, this is what you should get in the end. Awesome. Go and try those questions that are mixing negative exponents and the product and the quotient rule together.